Good evening, Bhaskar and Sujita. Let us get started. Flux MMF waves in induction motor. For example, अब बस ये देख लेना, मान लो ये वाला स्टेटर है एंड आपका कंडक्टर रखा है, इधर रखा है, दो कंडक्टर मान लो, which is of into the plane, out of the plane, stator का. I'll tell you why I have drawn that. ये वाला रोटर है, रोटर में रोटर के ऊपर भी कंडक्टर्स रखा है. How that is kept? Two conductors are one turn. This is into the plane, out of the plane. आप ऐसा कर दिया तो इसका MMF कैसे लिखना है, मतलब look at here, no, I'll put on the video so you can see here now. Red line curling, the thumb is inside, curling finger direction is MMF or the flux direction. So perpendicular to that, we'll draw. So this one I'm talking about stator MMF, perpendicular to this stator MMF or stator flux. This is F1 or phi 1. Stator MMF or flux. What about the rotor? The rotor may be inside. I have given inside वाला देख लिया तो current thumb direction है, flux curling finger का है. तो rotor में this is what I have on the rotor. F2 or phi 2, I would say. Rotor MMF or flux. Now, what will happen here now? These two fluxes or rotor get interacted to produce a torque, like what we have seen. So, for example, this is the perpendicular line angle, right? This is 90, and this is some theta 2. So, torque which is equal to the torque proportional to F1, F2 sine of angle between these two. कितना होगा? 90 plus theta 2. I know actual torque equation. What is the torque equation? I can have it here now. If you look at the synchronous motor torque equation, synchronous motor torque equal to some K. If you remember that, I have given that pi by 2 P by 2 whole square FF phi R sine delta is the formula. Similarly here now, what I can do here in this case, torque is proportional to some constant K. F1, rather than saying FF is field, so corresponding this one is F2. And field either rotor or rotor state, I mean induction motor में synchronous motor में field is nothing but rotor here now FF, and phi R sine of 90 plus theta 2. So torque will be K F2 phi R cos theta 2. What is theta 2 here now? Theta 2 is coming from rotor. So I would say here now tan theta 2 Sx2 by R2. Theta 2 is tan inverse of Sx2 by R2. You might have asked the question, you should ask the question, अरे मैं ऐसा क्यों ड्रॉ कर दिया, इधर क्यों ड्रॉ कर दिया, इधर क्यों कर दिया, क्योंकि F1 F2 का डिस्टेंस कितना होना चाहिए, नॉर्मली 130 to 140 डिग्री होना चाहिए. अगर ट्रांसफार्मर में कितना होना चाहिए, ट्रांसफार्मर, look at the transformer, because induction motor is a rotating transformer. F1 means I1, F2 means I2, primary current, secondary current. What is angle between primary current, secondary current? Look at here now, transformer. This is in transformer because both are same, except the only the magnetizing current. This is I1. I would say at supply voltage V1. I0. Do you remember the transformer? Comparing the transformer and this equation 5. E1 and E2 here now, and this is I2. So I2 dash. This is I2 dash. So where is I1? I1 is here now, resultant of this. So angle between I1 and I2 here normally in transformer, that's around 170 to 180 degree. But the angle between I1 and I2 in this induction motor, it is around, as I mentioned, 130 to 140 degree. क्यों इतना फर्क पड़ रहा है यार? क्योंकि इसमें I0 का वैल्यू वेरी लेस, ट्रांसफार्मर में I0 is 3 to 4% of I rated, but here I0 is 30 to 40% of I rated. इसलिए इसमें एंगल, ये दोनों का एंगल 130 140 हो, इसलिए मैंने इसे ड्रॉ कर दिया. Meaning you should show that I1 and I2 has some angle. I1 and I2, F1 and F2 has some angle. इसलिए मैंने ऐसा दिखाया. ठीक है? So induction motor is like transformer. You can see दोनों compare करो. Induction motor is rotating, so torque is depending upon this expression. So I have taken from the synchronous motor. So I have obtained the torque expression here now. Okay, please copy this. This is how MMF and the fluxes will be here now. Induction motor MMF, the fluxes will be guided by this expression. theta 2 is here now. From the rotor it comes. Yeah, this k is, if you want, you can write k also, same thing. Pi by 2, p by 2 whole square only. Or a constant. F2 phi r cos theta 2. So I would like to see the equivalent circuit now. Let me see how the equivalent circuit of this induction motor will be. मैंने बताया ट्रांसफार्मर और इंडक्शन मोटर प्रिंसिपल was same है, लेकिन इंडक्शन मोटर is a rotating transformer. So equivalent circuit also will similarly looks like same, but इन दोनों में फर्क क्या पड़ेगा we'll need to see. Okay, let me move on. Copied. So let me move on to equivalent circuit. Same as a transformer. Okay. This is rotor and stator here now, and in between we have a R1 JX1. This is V phase. RI JXM. Look at here now. What is a rotary? These things. A rotor voltage induced is, you can say here now SE2 rotor ka equivalent hai na, and this one is X2 dash, or sorry X2 R2 dash by S, and this is E2 X2 R2 by S E2, and E1 is the voltage. A is to 1 turns ratio, क्योंकि स्टेटर का साइड ज्यादा टर्न्स हो. कन्वर्ट इनटू प्राइमरी साइड में कन्वर्ट करो. This is variable because slip speed can change. Dash by S. X2 dash X1 V phase RI JX. इधर है ना voltage, which is E1 अंतिम T2 dash. Current देख लो I1 I2 here, and this is I0 I2 dash I1 I0, सेम जैसे ट्रांसफार्मर. इसके बाद हमने क्या किया ट्रांसफार्मर में, सीरीज एलिमेंट्स एक तरफ लेके आए, शंट एलिमेंट्स दूसरा तरफ लेके आए. Here I can't do that way. because most of the current 30 to 40% is major. XM value is very less compared to RI. XM is very less compared to RI. So most of the current is major. Is matlab I mu current. I mu current is kind of, or rather I would say here now, is 30 to 40 of rated. So what I can do, what I can do is only can ignore RI. You cannot ignore XM. So I can say here now, maximum approximation. What I can do is only this one. So R1, JX1, or XM. This is approximated or neglecting RI. That is neglect RI. Otherwise, you should not do it. This is the final expression only. R1, J1, JX2 dash, R2 dash by X, and we face I1 and I mu and I2 dash. By the way, a values क्या हो गया? Tell me now E2 dash. What is E2 dash? You're coming to lower terms to higher term side. E2. What is I2 dash? I2 by A, lower to higher term. What is R2 dash? You're coming to lower to higher. A square R2. X2 dash. A square X2. These are the transformed values from secondary to primary. So from secondary to primary, I can say here now. A2, I2 by A square R2. You can see this. So the final expression is equivalent circuit is this one, or approximately you can use this. Note, you please write a note here now. Unlike the transformer, please write a note here now. Unlike the transformer, shunt elements and series elements cannot be drawn separately. Unlike the transformer, shunt element and series elements cannot be drawn separately. As magnetizing current drawn by the induction motor, is 30 to 40% of rated current. 30 to 40% of rated current. Okay. Okay, fine then. So now in this case, equivalent circuit is done here. Now in this case, I would like to see even the losses also approximated. As I mentioned here, now approximated cannot be made. Left side or right side you can't make. ये वाला स्टेटर का वन साइड होगा, रोटर का वन साइड होगा, बीच में कोर का एलिमेंट्स हो जाएगा. That's all. Now I would like to see the power across the air gap or the power flow analysis. Power flow in induction motor. Let me see the power flow in the induction motor. ये वाला important है, ये टॉपिक आपको important होगा. So ये कैसे पता चलेगा power flow here now from the equivalent circuit only. Let us see the equivalent circuit, then I'll come to the power flow. Just redrawing that. This is the exact one. Okay, now whenever I say power flow here now, for example, this is the flow, output is here, and you are giving the input. Stator ka input there. This is what you are giving stator input. So the input value is root 3 VL IL cos theta. P only, right? Loss means it's a P. Root 3 VL IL cos theta. Now what is the first loss here? What is the first loss? Wherever the resistance is there, that's a loss. You can see the R1 here now. इसमें R1 है ना पहले. R1 is stator resistance. So उसमें क्या है? तो पहला वाला loss क्या होगा? Stator loss PS. So PS क्या है इधर? Stator copper loss. PS क्या होगा? Stator copper loss. उसके बाद क्या होता है? Inductance में loss नहीं है. Then core. ये resistance है ना? Core. We call it as a kind of iron loss here now. PI. And PI is iron loss or core loss. Loss के बाद whatever is left over here now, इधर है ना, इधर जो भी बचा है, ठीक है, that is called leftover power is called PG. So that PG is called air gap power. Air gap power must be input से ये दोनों losses को subtract करना, stator copper losses को, iron losses को subtract करना, आपको ये मिलेगा. उसके बाद क्या है इधर? इधर कौन सा लॉस है? Again, what is the loss? रेसिस्टर है ना इधर, इसमें लॉस नहीं होगा, इंडक्टर में लॉस नहीं होगा, तो रेसिस्टर है इधर, रेसिस्टर में कौन सा लॉस होगा? पीसी. पीसी इज rotor copper loss. Then whatever left is called as a PM. This PM is nothing but mechanical gross power. इसके बाद there is no resistor है, output आना चाहिए, लेकिन another one which I represent is friction and windage loss. One which I represent is PFW. Friction and windage loss. Then output. So now, how can you obtain here? No, mathematically, ये वाला exact है. This is exact one. Sometimes what will happen is iron losses, frictional and windage losses combine करके देगा. जब आपका iron and frictional and windage losses combine करके देगा, उस समय आप क्या करना? Iron और frictional and windage loss को इस तरफ लेके आना चाहिए. So approximated one लिख रहा हूँ मैंने. और this is what I will say if PI PFW is combinedly given. प्रॉब्लम में ये दोनों कंबाइन करके दिया. So then loss flow कैसे होगा? Then आपका एक्सप्रेशन होगा, this is how it will be. And I have input. First one is PS. Otherwise I'll use the same color if you want me to use. This is PS, stator copper loss. Then PA इधर नहीं होगा, तो left over is PG. उसके बाद copper loss में जाएगा PC. और क्या बचा है इधर? Mechanical gross power. उसके बाद loss में क्या जाएगा? Iron loss इधर ऐड करना पड़ेगा, PIFW. तो क्या बचा है finally? This is the PSH we call shaft power or output power. PSH the shaft power or output power. So this way we can do this one. PG is here now. Input minus PS will give you PG. PG minus PC will give PM. PM माइनस PFW विल गिव PSH। और अगर आपने राइट साइड से आ रहे PSH प्लस PFW KCL जैसे यार, देखा ये दोनों बाहर जा रहे, ये दोनों बाहर जा रहे, ये दोनों कंबाइन करो, ये मिल जाएगा। ये बाहर जा रहे, ये बाहर जा रहे, ये दोनों कंबाइन करो, ये मिल जाएगा। नहीं तो इधर से इसको सब्ट्रैक्ट करो, एंटरिंग है लीविंग है, इसको PG से PC को सब्ट्रैक्ट करो, PM मिल जाएगा। ठीक है, so this is how the loss flow will be there here. So now mathematical treatment करना है, so please copy this. First copy करना please. Problems on this are very important. There are gate questions also. इसके ऊपर बहुत सारा gate questions है. At least alternate here I see a question. So problem भी करना है इसके ऊपर. Let me move on here now. Mathematical treatment. So if it is a mathematical treatment here, I'll show you the flow again, don't worry. Exact one. So this is input, PS, PI, and PG left, PC, and PM, PFW, this is PSH, PN, this is input. So the PG air gap power is the power which is existing here now. This is I2 dash. So इधर है ना, जो भी पावर इधर एयर गैप में एग्जिस्ट होगा स्टेटर और रोटर के बीच में, that is a PG. So the PG can be, it is three phase है ना, total three phase power है, 3I2 dash whole square R2 dash by S, and PC copper loss. इसमें कॉपर लॉस है, रेसिस्टर R2 में कॉपर, मैंने इसको सिंप्लीफाई के लिखा लेकिन एक्चुअली रेसिस्टेंस R2 डैश है. सो कॉपर लॉस होगा 3I2 dash whole square R2. PG is area power. I told you already. So now looking at this, can I say PG equal to numerator 3 I square R2 PC by S? So from here, PC equal to SPG, equation 1. PC आ गया. PM कैसे आएगा? PM का वैल्यू चाहिए PG माइनस PC. इधर से इसको सब्ट्रैक्ट करो. PG माइनस PC. इसको कैसे लिख सकते हैं? One way to write is in terms of PG you can write it. In terms of PC you can write if you want. If you want to write PG in terms of PC, yes. PC by S minus PC. So PC common layer 1 minus S by 1. You can write in terms of this also. Otherwise, if you want to write in terms of PG, PM equal to PG minus PC is SPG one minus S into PG. Right? Let us solve a problem on this one so that you'll understand. See, there are two ways of questions are asked. एक तरफ क्वेश्चंस कैसे होगा, आउटपुट का वैल्यू देगा तो आउटपुट से पीछे आना चाहिए, ये वाला आउटपुट से पीछे आना चाहिए एक एक को कैलकुलेट करने के लिए. दूसरा तरीका प्रॉब्लम कैसे होता है, इनपुट का वैल्यू देगा आगे से, मतलब इनपुट से आगे जाना पड़ेगा, PS, PA, PC, PF, W. सो लेफ्ट टू राइट डायरेक्शन में. उस समय आप एक एक को सब्ट्रैक्ट करना पड़ेगा. अगर इधर पीछे से मतलब वापस आ रहे, मतलब इधर से वापस आ रहे पीछे को, तो उस समय एक एक को ऐड करना पड़ेगा. समझो PSH प्लस PFW ये मिलेगा, PM प्लस PC ये मिलेगा. I hope you understand two varieties of the problems. I think you got the context right what I am explaining. Copy that one please. Copied. Shall we solve the problem? Shall we? Okay, fine. Let us move on. Yes or no? Yes or no? Are you there, guys? Can you hear me? Okay, fine, so good. Okay. Let me clear this then. देखो क्वेश्चन को देखो, 3-phase इंडक्शन मोटर है. फर्स्ट ऑफ ऑल यू हैव टू डिसाइड आयरन लॉसेस, फ्रिक्शन एंड विंडेज लॉसेस कंबाइन के दिया या फिर अलग अलग दिया. सो दैट्स द फर्स्ट पॉइंट आप देखना है. अगर कंबाइनली दिया तो दूसरा पावर फ्लो डायग्राम ड्रॉ करना है, अलग दिया तो दूसरा ड्रॉ करना है. इधर क्या है, फ्रिक्शन, विंडेज, कोर लॉस कंबाइनली गिवन. तो कौन सा वाला, सेकेंड वाला ड्रॉ करना. सो लेट मी ड्रॉ दैट वन. This is PI, PIN, so PS loss कंबाइंड लिखिए दिया है ना. सो PG इधर है, उसके बाद PC, whatever left is PM. Here combined लिखिए PIFW, and this is PSH. So what is that is being asked here? PC calculate करना. What are the things given here? PSH दिया है 16 kilowatt, friction, windage, core loss combinedly given as 1.2. So this is also 1.2 kilowatt. तो PM कितना हो गया? What is the PM value? Here, right? ये दोनों combine करके आएगा. PM is PSH plus PFW. 16 plus 1.2. 17 kilowatt. Mechanical output power. But what is the task? PC चाहिए. How to get PC? PC के लिए formula in terms of PM. PM into, look at our formula, 1 minus S. Previous formula we have used. So you please substitute this one. Just now I have given PC and PM correlation. ठीक है, तो वो यूज करो. या स्लिप चाहिए. What we can consider is compute the following if slip equal to 0.04. मतलब वो स्पीड देना चाहिए, स्लिप कैलकुलेट करना चाहिए, बट आई हैव गिवन स्लिप डायरेक्टली. स्लिप एस इक्वल टू 0.04. सो PM is 17.2, 0.04, 1 minus 0.04. This is copper loss. So what is this value? Can you please tell me? What is the copper loss? Calculate that. Then ये आएगा, तो ये PM मिला. This is 17.2. ये आएगा, ये दोनों कंबाइन करो, PG मिलेगा. PG प्लस PS ऐड करो, PN मिलेगा. ओके. Bhaskar, how much point? Okay, kilowatt, 0.71 to kilowatt. Nice. 0.712, I think 0.716. nice. Kilowatt. So इधर वाला 0.716 kilowatt है, तो PG कितना आएगा? What is PG here now? ये तो कंबाइन करो, PM plus PC. So what is that value? 17.2 and 0.7, around 17.916. PG मिला, this is 17.916. PS is given 800 watts. So 800 watts means 0.8 kilowatt. तो ये दोनों कंबाइन करो. ये दोनों combine करो 17.9 and 18 something and 18.8 approximately. I'm just making. So output 16 है, input 18.8 है. To answer the second question, input कितना है? This is 18.8 kilowatt. Efficiency चाहिए. Output by input. Output is 16, input is 18. How much is that? Around 18, 86%, 85, 86. Yeah, good Bhaskar, 85%, around 85, 86. Okay. So let us move on to next one. Torque slip characteristics. So mathematically torque versus slip का characteristics obtain करना है. I know that torque into omega, which is equal to Pm, mechanical gross power. So torque mechanical gross power is 1 minus S into Pg. Just now we have obtained. And also I know torque into omega also can be obtained based on the slip. 1 minus S into omega S. 1 minus S into Pg. Because slip definition I know, so from there we can obtain this. 1 minus S get cancelled. So torque into omega S is this one. So torque equal to Pg 1 by omega S. Pg क्या है? 3 times I2 dash whole square R2 dash by S. This is the expression torque versus slip. लेकिन करंट कितना है? करंट कहाँ से? सर्क्यूट देख लो. हमारा सर्क्यूट कहाँ है? हमारा सर्क्यूट इधर है, ये वाला. x2 dash r1 jx1 v phase ri jxm. This is I2 dash. We'll see the networks in network theorems, Thevenin's theorem. What does the Thevenin's theorem says? इधर का current चाहिए ना? So what I do, I'll take this as a separate network, and the rest of the network I'll consider Thevenin's equivalent. So Thevenin's equivalent, I'll explain in detail in networks. इसको Thevenin's equivalent can be written as VTH in series with this is VTH in series with ZTH, that is RTH and JXTH, and rest of the elements. ये वाला actual current आप निकालना चाहिए, JX2 dash R2 dash by ये वाला current चाहिए I2 dash. So what is I2 dash here now? I2 dash magnitude can be obtained voltage by impedance, VTH by square root of impedance RTH plus R2 dash by whole square plus XTH X2 dash whole square. ये वाला इधर सब्स्टिट्यूट करो यार टॉर्क एक्सप्रेशन में, तो कितना बड़ा एक्सप्रेशन आएगा देखो, 3 by omega s I2 square VT square by RTH R2 dash by s plus XTH X2 dash by s into R2 dash by s. This is the torque versus slip equation. लेकिन क्या हमको कैसे पता चलेगा प्रोपोर्शनेट या इनवर्सली प्रोपोर्शनल, डायरेक्टली प्रोपोर्शनल और डिपेंड नहीं हो रहे, हमको कैसे पता चलेगा? इतना बड़ा एक्सप्रेशन है इधर, बहुत बड़ा एक्सप्रेशन है, स्लिप इधर भी है, स्लिप इधर भी है, टॉर्क इधर है, तो हमको कैसे पता चलेगा? I'll do the approximations later, but I know the characteristics for this one, torque versus slip. I'll draw the first here now, then I'll try to explain. Approximation लेके आपको समझ में आएगा, approximation लेके आपको समझाऊंगा पूरा, ठीक है? तो whatever I have drawn is correct or not. First let me draw the torque slip characteristics. Corresponding mathematical expression क्या है? This is the mathematical expression for torque versus slip. Okay. Now let me draw that. Please copy that one first of all. Okay, good Saho. So let me draw that characteristics here. How this torque slip characteristics occurs, and let me explain that. slip is okay, n is 0, n0 to slip 1 you can calculate ns minus n by ns is equal to 1. As the speed increases, slip becomes 0. This side s is kind of greater than 1, s is less than 1. You can see here now the characteristics are and this is how the characteristics look like. And a point where it is joining here now, this is n equal to ns and slip equal to 0. 0 to 1, this is generator mode. 0 to 1 means your n is kind of less than ns. And from this mode, this one, this is motor mode, sorry. That's where we're operating with. Motor mode. इसके बाद s is less than 0 and this is generator mode. Of course, your n is greater than ns, इसलिए s less than 0 होगा. Look at this portion. S is greater than 1, meaning you're trying to rotate in opposite direction. So this one is, we have seen in DC motor, braking mode. So S will be greater than 1. Let me define the things here. This is maximum torque. This is starting torque. And this one is full load torque. So I'll write it here. Maximum torque. This is starting torque. And T is full load torque. Starting torque not during starting में, when n equal to 0, उस समय आपको कितना टॉर्क मिल रहा है स्टार्टिंग में? मैक्सिमम पूरा मशीन, सो कितना मैक्सिमम टॉर्क देगा? फुल लोड मींस नॉर्मल रनिंग कंडीशन, इसका करस्पॉन्डिंग स्लिप है ना, यस फुल लोड. नॉर्मली दिस इज 4%, दैट इज 0.04. मैंने एक प्रॉब्लम भी दिया है. So the thing is here now, if you do the approximations, let me do the approximation. Torque कहाँ हो गया? Torque will be there on the rotor. Torque will be there on the rotor. So what I do the approximation here now, I want to do the approximations, which is BTH is V phase and RTH and XTH both are 0. Then equivalent circuit becomes here now. This is the equivalent circuit, V phase and I2 dash, X2 dash, R2 dash by S. Now what is I2 here now? What is I2 dash magnitude? This is V phase by square root of R2 by S whole square, X2 dash whole square है ना? Current, इसमें current चाहिए. Torque क्या होगा? Torque equal to 3 by omega S. Torque into omega 3 I square R2 by S है ना? I square is this. I'm just directly writing here now. I square R2 by S whole square, X2 dash whole square. ये वाला कहाँ से आ रहे? This is where it is coming. Don't get confused. Current substitute कर रहा हूँ बस मैंने. Current का वैल्यू इधर है ना, current substitute कर रहा हूँ. Into R2 dash by S. Approximation कर रहा हूँ यार. Look at here now. What is during running condition? When running condition slip क्या होगा? Slip is kind of very less than 1. Normally it is equal to 0.04, which means that R2 dash by S is pretty much greater than X2 dash. तो आपका टॉर्क का एक्सप्रेशन क्या होगा? इसको नेग्लेक्ट करो, R2 by S स्क्वायर है, एक R2 by S है, एक कैंसिल हो जाएगा. So what we are left here now, finally I am writing T equal to 3 by omega S. This get cancels out, this get cancels out. It will go on to the top. Yes, V phase squared by R2 dash. Look at here now. Your torque is proportional to slip. Torque is proportional to V square. When? During running condition. You can see here, running मतलब ये वाला है. S 0 है इधर. S increases, this side S increase हो रही, तो आपका torque increase हो रही, देखा? S increasing here now. Yes, 0.04, 0.08, 0.5, 0.6. That's a running condition here now. Increase होगा. Not in the starting. Running condition means आपका operation इस तरफ ही होगा. As the slip increases, torque increases. Torque proportional to slip. That I can make it out. And ये वाला important expression है, बहुत सारे जगह पे ये use करूँगा. Torque equal to 3 by omega S, SV square by R2 dash. I'll use that one at multiple places. Similarly, maximum torque चाहिए. Let me get the maximum torque also. So maximum torque कैसे आएगा? Let me see here now. First copy that, please. I hope you understand this point. ये वाला, this is मान लो 100 square, 10,000. This x2 is 1 only. 10,000 plus 1, 10,001. I'm making 10,000. Just example दे रहा हूँ आपको. तो मैक्सिमम टॉर्क का एक्सप्रेशन आना चाहिए. मैक्सिमम पावर ट्रांसफर थ्योरम यूज करना पड़ेगा एंड स्टार्टिंग टॉर्क भी कैलकुलेट करना पड़ेगा. Okay, induction motor can operate in 3 modes. It means braking mode, motoring mode, generator mode. You can see here. Copied. Okay, so let me see the maximum torque. Okay, Rohit, cool. So, or the starting torque. हमारा टॉर्क एक्सप्रेशन क्या है? 3/ωs I2 dash है ना, V phase square R2 by S whole square X2 dash R2 by S. This is what I got approximate one. Starting torque means S equal to 1, that is N equal to 0. S 1 होगा ना, क्यों? This is the definition. So N 0 रखो तो 1 हो जाएगा. So torque क्या होगा? Starting torque is 3/ωs V phase square R2 dash whole square X2 dash R2 dash. This is the expression for starting torque. Full load torque. What is full load torque? So S equal to S full load. Substitute करो. Whole square X2 dash whole square R2 dash by S full load. This is full load torque. Now the maximum torque. So this is the maximum torque. So this is the equivalent circuit of induction motor, approximated one. So maximum torque मतलब maximum power आना चाहिए, maximum power transfer theorem. So if we use a maximum power transfer theorem, we'll see in details in networks. Here it means that maximum power आएगा when R2 by S equal to X2 dash. So I'll make this R2 by S is S max, for example. So means wherever the R2 by S or wherever X2 is there, replace with R2 by S max, or the condition is R2 equal to SX2. R2 equal to SX2 dash maximum torque के लिए. तो torque क्या होगा यार? Just substitute here now. इसमें substitute करना. R2 by S is X2 dash. To maximum torque, what will happen? 3/ωs. Very important, eh? R by S is X2 dash. X2 dash whole square. R by S is X2 dash. That's all from here. So it becomes X square X2 dash. One X2 dash get cancelled. So okay, it remained with very important expression 3/ωs 0.5 V phase square by X2 dash. So the important point here is that maximum torque is independent of resistance. Torque is independent of resistance. रेसिस्टेंस के ऊपर मैक्सिमम टॉर्क डिपेंड नहीं होगा, लेकिन कहाँ मैक्सिमम टॉर्क आ रही, मतलब कौन सा स्लिप पे मैक्सिमम टॉर्क आ रही, कौन सा स्पीड पे मैक्सिमम टॉर्क आ रही, is it at 100 rpm, is it at 200 rpm? So that depends upon the resistance. I repeat the point, maximum torque is independent of the resistance, but based on the resistance or the resistance, if you increase the resistance, the slip at which the maximum torque occurs can be controlled. Copy this, I'll give the statement to you. I'll give the statement anyway. So please mention that point. Maximum torque is independent of rotor resistance. Maximum, very important point. Maximum torque is independent of rotor resistance, but but the slip at which maximum torque occurs, Slip at which maximum torque occurs depends on rotor resistance. Slip at which maximum torque occurs depends upon rotor resistance. Next point. As the rotor resistance increases, maximum torque occurs or produces maximum torque produces at lower speeds. Maximum torque produces at lower speed. This is what I was talking about. मैंने statement क्या दिया इधर? R2 by S, which is X2 dash conditioning, na? As the rotor resistance increases, slip has to be increased to maintain the ratio. Slip increase matlab lower speed hai. That's what I was saying here now. So if I show this on the graph, to you, the slip is equal to 0. For example, its resistance is R2 dash. Now resistance is increased. So what will happen here now? This will come here now. Maximum speed, maximum. Look at here now. इसका resistance, ये वाला character is rotor resistance R2 double dash. R2 double dash is R2 dash. Resistance increase कर दिया. तो आपको क्या मिला? Maximum torque कहाँ है? This is what the maximum torque. ये वाला T maximum है. Blue line देख लिया तो maximum torque कहाँ मिला? It is slip S1. So here maximum torque कहाँ मिला? It is slip of S2. Slip S1 means speed N1, speed N2. Definitely S2 is less than S1. S2 is more than N1 because higher slips. So N2 speed is less than N1. Speed either 0 N equal to Ns. So speed increases in the slip in opposite direction. Slip 0 is equal to 1. Even you can further increase the resistance ताकि starting torque can become a maximum torque. Look at this one. इसका corresponding R2 triple dash. S3 is in fact 1. So I hope you understand this point. As the rotor resistance increases, you are getting the maximum torque or early lower speeds. That is really good here. In fact, मैंने बता दिया already बाइक का speed 0 है. फर्स्ट गियर में डालना चाहिए, उधर टॉर्क ज्यादा होना चाहिए फर्स्ट गियर में. जब हमारा स्पीड कम है उस समय टॉर्क ज्यादा होना चाहिए क्योंकि इनर्शिया ज्यादा है. ठीक है. When the speed is higher, inertia is 0 or less, you need not require large amount of torque. Normal full load torque is enough. So starting torque increase कर सकते जब आपने rotor resistance को increase करेगा. I hope you got that point. Okay. So there is, yeah, just copy this. There is a expression ratios for T start versus T full load. T start was T maximum ratios based on this one. Look at here now, मैंने दिया already. Starting torque 3 omega s, okay, V phase square by R2 dash X2 dash square, okay, and this is R2 dash starting torque है. Maximum torque को formula दिया मैंने 3 omega s 0.5 V phase square R2 dash or X2 dash independent of resistance. फुल लोड टॉर्क के लिए एक्सप्रेशन दिया है मैंने V phase square R2 by S full load whole square and X2 dash whole square and R2 by S full load. ये वाला expressions दिया है. I would like to take the ratios of this one. Second. One second, I'll just be back. Sorry. Okay. So T start, T maximum, T full load. There are gate questions on these ratios here basically. मतलब आप मान लो T start by T maximum ratio लिया 1/2. T start by T maximum will become 2 by S maximum by 1 by S maximum. Provided you need to replace R2 by S, R2 equal to SX2, all substitute करना 1/2 कर दिया था. Then if 3/2 is done, another expression is 3/2 means T full load by T max. If you take the ratio T full load by T max, then again 2 by S max by S full load by S max. What is S full load S max? You know, S full load is slip at full load. Slip at full load. What is S max? Slip at maximum torque is S max. So these two expressions are really important for examination. easy to remember also. Maximum common होना चाहिए. T start by T maximum तो S max by S starting. S starting by S maximum. Starting का slip क्या है 1 है बस. T full load by T maximum 2 by S maximum by S full load. S full load by S max. Simple to remember also. So ये वाला expressions are really important for you exam के लिए, क्योंकि we'll solve one gate question also here now. Let me see a gate question here. There is a gate question. We'll do that gate questions here now. And your syllabus will be done. The machines should be done in 2 days. Tomorrow, day after tomorrow, and 24th. Maximum it can go up to 24th single phase. By 24th it should be done. 3 more days. And even power electronics also same thing. Power electronics, let us see 25th. Chopper कल complete हो जाएगा कल सुबह. Inverter चालू करना है परसों. 23, 24, and 25. Yeah, syllabus is less chopper and inverter. मैं बता दिया आपको. So by 25th, I think these 2 subjects will be done. Both the subjects. So what I was saying here is a problem. Let me solve a gate problem. Starting torque of 150% and maximum torque of 300% of the full load. Find the slip at maximum torque. What is it given here now? This is what, if you see this one, torque versus slip, 150% of full load, 300% of full load. Matlab, look at this. This is shayad full load, T full load, corresponding its full load. This is मान लो 100 Newton meter. This is 150%. This is starting torque. And this one in a T maximum. This is what 300%, 3 times of full load. What there is asked, you need to find this is S max. Find the slip at which maximum torque. So क्या है इधर है? मैंने बता दी equations दिया ना आपको. T start by T max, 2 by S max by 1 by S max. 150%, 300%. 150% of full load torque, 300% of full load, 2 by S max, 1 by S max, 1 by 2, 2 by S max plus S max. एक क्वाड्रेटिक इक्वेशन आएगा, दो वैल्यूज आएगा, उसमें वैलिड वैल्यू लेना चाहिए. प्लीज गेट मी दैट वैल्यू. You will get a quadratic equation. You have to solve that one. Two values आएगा. एक तो मोटर का वैल्यू which is 0 to 1 के बीच में आएगा. दूसरा which is maybe in braking mode, more than 1 or maybe less than 0. Excellent, Sahu. That's good. It's a standard problem and its answer is 0.26. कौन सा लेना चाहिए? S max is 0.26. Okay. Continuation to this one is find the full load slip. Full load slip क्या है? Again the same expression. आप ये वाला लेना इस बार. T full load by ये ले लो. Full load by maximum 1 by 3 है ना, 3 times ज्यादा है. 1 by 3 2 by S max I know 0.26. S full load चाहिए. Get me this value. Now find the full load slip. Both the questions are asked in date. Any doubt here now? Substitution करने में taking time. Here also दो वैल्यू मिलेगा. You have to pick up one which is nearer to 0. तो इधर है ना, normal it is nearer to 0.04, 0.05, 0.06, something like that. And sorry, this is not S max. Sorry, there is full load है ना वाला. कोई बात नहीं है, full load. इसके full load की change करो, no problem. It's a ratio only. I want S full load, not S max. Ratio, right? ऊपर नीचे कुछ नहीं होगा, बस S full load चाहिए. Doing Sahu, Maskar, Sujita, Rohit, guys. Yeah, Sahu, one. No. One you have 10.26, right? One is 0.26 S max हो गया, लेकिन दूसरा S full load चाहिए. S full load is different. Is it 0.026? No, I think. Any other answer? 1/3 either. I don't know what you have taken. 1/3, 2 by simple quadratic expression आपको मिलेगा. Yeah, Sahu, it's around point. Yeah, maybe, yeah, that's correct. It's around, yeah, 0.042. I think it's around 0.07. I'll tell you the where the problem was. आपको एग्जैक्ट आंसर प्रीवियसली 0.268 आना चाहिए इस मैक्स में, तो 0.268 आप अपने 0.26 लिया है, तो शायद इधर सब्स्टिट्यूट कर दे तो शायद इतना डिफरेंस आया होगा. ठीक है, नो इश्यूज. दिस विल बी अराउंड 0.044% to 7%. You make this actual exact one is 7%, 0.07, but no issues. There is no problem. Okay, then I'll stop here. Thank you, Sahu, Savikant, Sahu, Rohit, Bhaskar, and Sujita. And just let's see. Thank you all, guys, and tomorrow morning we'll see you. Yeah, thank you, Sahu. Yeah. Yeah, thank you, Rohit. Yeah, thank you.